Hello, everybody, and welcome to today's live stream. My name is Angelo, and today we're going to talk about fixturing in Fusion. On the keyboard, as usual, I've got my good buddy and colleague, Brad Tallis, and I'm going to check really quick to see that everything's okay. Can you guys hear me all right? Brad, if you can give me a quick thumbs up. All right, cool. Okay, great. Thanks, everybody. All right, so today we're going to talk about fixturing. I'm a machinist. I've been machining for a while now, and in the shop environment, you get all kinds of parts that come through the shop, and you have to not only make the part, program the part, but you're going to have to fixture it. So how are you going to hold it? We've got vices, fixture plates, all types of things. And I'm going to share some examples of some things that I've done over the years to kind of give you all an idea and to open your mind to some methods of work holding. So thanks Jan. All right, thanks for saying that. All right, great. So let me share my screen. All right, so typically if you got a part, so this is a part I made a while back, and in the upper left hand corner, this is a 4140 steel. And it's easy to do, not easy to do. It's something you could easily do on a multi-axis machine, or if you have a 3-axis machine, you can grab it in a 3-jaw chuck on a 4th-axis rotary and just rotate it around until you hit all the sides, and then you would come and machine it off on the end. Very similar to like if you're on a lathe, you make the part and then you cut it off, and then there might be secondary operations. So this particular part here, this is how I made this part. The first time I came through the shop, threw it on the machine, and I started with some round stock, and I rotated it around and hit all the sides. The next image, but what if you don't have a multi-axis machine? You just have a standard 3-axis machine. So here's the same part, a little different iteration, slightly different design, but basically the same thing. So instead of having a multi-axis machine in this particular example, I just started with rectangular stock, and I machined some sides to make sure the material is accurate, not the extruded or the standard stock sizes. And then I just straddled it across 2 Kurt vices. And you can see in this image here, straddling across the 2, and I started machining the part. And then what I did is I just unclamped the vices, rotated it at 90 degrees, and continued machining the part. And I did that all 4 sides until I got to the final operation, which is here. And you can see where my cursor is, where I machined off the tab there, machined off the length of the part. And then on this side here, where my cursor is on the left-hand side of the part, when I rotated it at 90, I also machined that. And it depends on the material, depends on the size, depends on the weight of the part, and different factors come into play when you are tabbing. This is called tabbing. So I can't remember exactly the value here. It must have been about 20, 30 thousandths. And I just went to a bandsaw, cut it off, and then a deburr wheel, and I knocked off that edge. Now this is a prototyping part, so you wouldn't really process a part like this for high production. But if you're just doing a couple parts, 1 part, I don't have to build any fixturing this way. So that's why I did it like this. Next, here's another part that I machined. And in the top right image, again, it's a stamping part, it's steel. And again, I had to just make a couple of parts. I didn't want to make any fixtures. And so I just held it with the raw stock in the vise, and I rotated around the A axis, and you could see how I processed it. So this side here is all finished, and then this is all just the material holding it. In the next image, I show how I machined that little channel in here. So on this face of the part where my cursor is, you could see it's kind of like almost like a V shape. So I made this quick fixture block with that same contour in there. I drilled and tapped a couple of holes, and I just used a flathead screw to nest it in there and hold it in there. Again, this is just prototyping, so it doesn't have to be super tight tolerances. And then I use the 4th axis rotary again, so my end mill can reach down into that cavity and produce that undercut in that area. So again, just exposing you guys to some ideas on some methods when you have parts coming through the shop. Because if you look at this part, the first thing you say is, oh my goodness, how would I make that? So that's how I banged it out and made it work. All right, so the next image, I like and I lean towards Lang 0 point. Also the Rock Lock from 5th Axis. It's great because it's super modular. You bolt this plate to your table, and then these blue caps, they come off. Whoop. Sorry about that. I accidentally clicked with my mouse. So these blue caps, they come out, and then these black pull studs, you can see them mounted on the bottom of the vise and the bottom of this tombstone. So those 4, so this is a 96 millimeter square pattern. These pull studs go into here, and as you tighten this or loosen it, it will tighten or loosen on these pull studs, and it'll hold the vise down, it'll hold the tombstone, any riser blocks. Very modular, so you can see here in the bottom right-hand corner, there's 4 of those plates, so you can use these 4 here in the lower left or upper right, or you can just straddle across and put it right on the center. So I like systems like this because it's very modular. Because if you have something like this, like the Kurt vise, you bolt that to the table, you have to indicate it, things like that. But if you have a 0 point system, there's no indication needed. Once this is bolted to your table, you could quickly, in the matter of a minute, pull out a vise and put in a tombstone, pull out a vise, put in a fixture plate. So I really like that. Oh yeah, and for everybody, let me go back to here. Also, if you have any questions, post them in the chat, and Brad will send those over to me. We have a shared document, and I look at those, and I'll answer those questions as we go. So make sure if you have any questions, drop them in there, and I'll do my absolute best to answer those for you. Okay, coming back here. So the next image, here's a part I made. And in the first operation, you could see I held it in a vise. And then I walked around the outer contour. I machined the cavity, the pocket. I drilled and tapped all these holes here. And along this edge where my cursor is this edge here. If you look in the bottom right, it's kind of a slightly curved and there's some holes in there. So when I made this part, I look at how am I going to hold it once I finish the first operation. So someone said, I like Lang too. Did you notice the HWR rotary riser? No. Can you clarify that, please? All right. So when I look at a part, I think to myself, as a machinist, I think to myself, how am I going to hold it? What features are on the part? Are there through holes? Are there reamed holes? Are there threaded holes? Are there locations for a dowel pin, perhaps? Are there any features that I could leverage or utilize on the part so I could hold it on a secondary or third operation? So on this particular example, I did exactly that. So there's these threaded holes, and this is like a cover, if you look in the bottom right. So there's these threaded holes, and I thought to myself, okay, that'll be great. And again, sorry, I clicked with my mouse, sensitive mouse. So I thought to myself I would just leverage those holes. So I machined the first operation like this, in this orientation. And then what I did, I don't have an image here, but I have a fusion example I could show you. And then what I did, I took it and I rotated it and I clamped it to a tombstone. Actually, I have it right back here. So the first operation was here. I machined these features, the pocket, I walked around it, put those threaded holes in. And then what I did is I took this vise, I loosened it with this screw down here. I left the part in the vise, and then I moved the vise over to the tombstone. And then it's still being held in there, so it's perfectly aligned. And I put in the holes, and I don't have the model because I can't really show that, but and I cut the contour, I put the holes in there. And then what I did for the third operation, I then took this part, flipped it over so you can see the holes there. And if I do like a section analysis here, let's go section analysis here. Let's see if it'll show. So then here you could see this part here. And what I did, I don't have the socket head cap screws, but they came from the bottom and they bolted into those threaded holes. And that's how I located it. And then let me cancel out of that. And then I flipped it over. So that was this image here. So from the bottom, there's threaded holes in the part. And then I've got this fixture plate. So you can see where my cursor is now. That's the fixture plate. And then this part here is the finished part. And again, there's threaded holes in there and the socket head cap screw coming from the bottom to hold that part. And then this image here, the part is almost done. There's some more features need to be put in there. And so all this material here at the top got removed. So that's how I did that part. And then let's see, the next image. Looks like there's a question from Stuart Duncan. Without let me go to here. Without using 0-point equipment, how would you pick up G54 for the second side? That's a great question, Stuart. Let me go back here. So what I've done in the past is if you have a part like this, you could perhaps pick up on a hole. You can put a hole in there, or you create a feature in there so when you flip it over, you'd have a reference. And I did a live stream a while back that talked about that. And if there's time at the end, I can show you exactly how to do that. But one of the ways I do it is to create a hole or a feature that when I flip it, sometimes you'd have to deck it off to machine that hat off the end. So if I come to here, so where my cursor is here, Stuart, what you can do is you can machine a precise bore or something like that. So then when you flip it over and you got that hat sticking out the top, you have something that you can pick up your X and Y. And then the Z would be easy because I could pick up Z off of that face before I mount the part down. So I'll set my G54Z, mount the part, probe that bore for my X and Y of G54, and I'm done. I'm good to go. Hopefully that explains one of the techniques you could use. All right, so the next part, here's another part I made. And this part was kind of big. I did hold it in a Lang, and where my cursor is, that's the finished part. Right there, that's the finished part. And this is a pretty big piece of stock. It was just a one-off. So I didn't really care too much about any material waste. Prototyping environment. Again, in a production environment, you wouldn't do something like this because that's a lot of wasted material. But the reason why I did this is so I could finish the part in one operation. I don't have to build any fixtures. I could just attack all sides of the part. So I'm holding on to 3 millimeters on this Lang vise. And I can rotate the part around and hit all sides. And you can kind of tell, it's kind of not, you can't totally tell here, but in this image, but I have another image that'll show it. But on the edge of the part here, I machined a window. So my end mill for my drill, because there's, on this edge of the part, there was some drilled in ream holes. And also on this part here, and there's some sharp corners that I had to access from this window. So I tilted the part up and machined those features in. I also just machined away this area because there was a sharp corner there where that boss is sticking up. And then you can see these tiny tabs on here that I came through and machined those off. And for a part like this, I would leave only like 5 or 10 thousandths when it's completely done. I would leave them solid like this here. Do all the machining as much as you can, and then you'd remove them. And I generally remove up here first because the base is down here, so it's super solid, right? So I wouldn't remove these tabs to 10 thousandths and finish these last. I would cut these first, leave these tabs here solid, and then lay it on its side in this orientation and machine away those tabs and leave about 10 thousandths. All right, so I see Jan says, I was wrong. It wasn't HWR, but Thame Workholding. They recently brought their so-called multi-rad Lang pattern with rotatable rectangular pattern at 90, like the Lang twin base. Yeah, okay. I've heard of HWR. I have not heard of Tame or Thame, but I'll certainly look into that. And yeah, it's a very modular system and makes machinist life easy in the shop. And again, like quickly on this one here, so this round plate was always mounted on the machine, and I could remove that vise and put a tombstone, put a fixture plate, or something like this in this image. So here, similar part like the one I just showed you, it was just larger. So I was afraid if I was holding onto 3 millimeters and I rotated on its side that it wouldn't be really rigid. So what I did, this is a aluminum material, and just on the bottom here where my cursor is, I drilled and tapped this 96 millimeter. I don't know what's wrong with my, I don't know why my, there it is. My mouse is super sensitive, sorry about that. So I drilled and tapped this 96 millimeter pattern. And I put these pull studs in, and then I mounted that pull stud directly into that 0-point system. So I had a riser on there so I could access the part. Because when you tilt the A axis or B axis, depending on your machine configuration, and it's sitting at 90 like this, and you reach down in this area, you need clearance from the table. So I just mounted on this one here the pull studs directly. And you can see here I got this window in there, and along this edge of the part there's drilled and reamed holes. And I just put this tab in here to hold it, and I got creative. You need to think outside of the box and get creative, so you could just bang out a part really quick. Again, in a production environment you wouldn't really do this because it's a lot of wasted material, but on a prototype one-off part you need it yesterday. I don't want to build any fixtures to hold this part. So the next one, because my mouse clicked forward, sorry about that. Here's a part I made, and how did I machine that? Looks like there's another question that came through. Arnie Patino, follow-up question on Stewart's. How would you make sure part is trammed in line with X and Y? Okay, great question. So when I bolted this from the bottom, I knew the application of this part, so I didn't have any dowel pins or anything to locate it. I knew that the through holes I created was good enough for this prototype part, because this would be a casting or something like that down the road. Just needed a quick prototype, so accuracy wasn't critical. But this fixture plate that I created in there is perfectly in line with X and Y. And so if I did have some critical features, you could put a dowel pin. Obviously you can check with your engineer and see if a dowel pin is good to locate it. But generally there's some features you can pick up and align it perfectly. Again, I did a live stream a while back. I can share that information. Thanks, Arnie, for that. Okay. So here's another part I made, and prototype needed it really quickly. And you look at this part and you think, oh my goodness, how am I going to hold that? And again, I needed it quickly. I didn't want to spend too much time building fixtures. So what I did is step one here, held it in the vise and machined everything here and finished what I could. And then this top area here, I purposely created this boss sticking out of the top. And you could see it a lot more in image 2 when I tilted it on its side. I machined all these features the best I could, whatever I could reach. I rotated it again and machined all of this area. I rotated it again, machined all of this area. And then I eventually came back to this side and finished what I could. But where that yellow arrow is, on this face, I drilled and tapped. This is kind of goes to your question, Arnie. I drilled and tapped some threaded holes. I also put a couple reamed holes in there. I had 2 reamed holes. They're not in this image. I sadly didn't grab a picture of that. But then this is what it looked like. And in this area here again, imagine there's 3 threaded holes in there with 2 drilled and reamed holes. So then when I flipped it over, and I'm going to show you in Fusion a little better idea of it. Then what I did, I had a fixture plate with the Lang pull studs that bolted to the 0-point base. And then from underneath, I had socket head cap screws that went into this area here. And then I finished this side, and you can see the tabs. There's 2 here, 2 here, and 1 here. And I machined everything I could. And at the very end, when the part was completely done, again, all these critical bores here, I machined at the very end, so they were all in line and perfect. And so I finished those features, and then I came in and just did a 2D contour, stepping down until I left about, in this case, they were about 10 thousandths, 20 thousandths, something like that, or 1/4 millimeter, 1/2 millimeter for the metric audience. And then I broke them off, and again, this is a prototyping environment, so we would just come in here and just buff off or grind off that feature and smooth it out. Prototyping environment, totally acceptable. Production environment, I would make this part differently. So that's it for the PowerPoint. But here, I'm going to show you what I did in Fusion on that very last part. So this is the one that I was talking about. So let me, if I toggle the colors so you can see. So here's my table with the 0-point. And then I had this pink plate in here. And on the bottom of that, I had the, let's hide this one. So I didn't model it in, I just quickly slapped this together to give you an idea. So on the bottom of here, I had the pull studs that mounted into this, and that would hold that down. And then I had a counterbore through hole that went from here into this part from the bottom. So there was socket head cap screw coming from the bottom, bolting into the yellow part there. I don't know why the colors are doing that, strange. But the socket head cap screw was holding it, and then the 2 dowel pins would locate this part. So that's how I processed that part. Let me look at the questions. Brad, thanks for handling that. And so this was just some of the ways. I just want to expose a couple of ways how I process parts, how I hold parts, how I fixture parts. And then I'm going to show you in Fusion where we have cam samples, and a lot of these work holdings are already in Fusion. So let me show you where those are. So if you go to your data panel, so top left-hand corner where it says show data panel, you can go to the data panel, go to home, and scroll all the way down. I have quite a few projects. So if you come to where it says samples and then cam samples, my mouse is super sensitive today. All right, so you come down here below libraries where it says cam samples, double click on that. And we have a lot of samples in here. We have work holding machine tables, things of that nature, some sample parts if you want to ever review any of these. So we do provide some samples in there. I do recommend some of these, like 3D milling. I did a live stream on that. 2D, if you're new to Fusion, you can review those, and it'll actually have the operations and all the settings. You can take those, copy them, and paste them into your file or your document and carry on. So what I wanted to show you is we have these machine tables. So you can come into here, grab the Haas. You can click on any one of these. I'm going to show you how I built this. Actually, the one that Brad had created for the thumbnail for the live stream today. So I'm going to show you how to do that. So if you click on one of these, right mouse click, it won't let you. You can't insert that into the document. So what you do, you double click it and you open it. So I'm going to start with the table and then the 0-point base and then a riser. And instead of this fixture, I'm going to put a vise on top. So you open up the document that you want. So I want the UMC 750 table. You can take any one of these. Double click that. It's going to open up. Then I'm going to go back to cam samples. So now I have that table there. And I'm going to go to work holding. And I'm going to come to Lang. And we have macro grip. So macro grip are all the vices. These are metric. We have imperial. And then you have Profilo. That's the aluminum soft jaws with the socket head cap screws from the bottom. We also have in here the 0 point. So these are the bases, and that's what I'm going to use. But I'm also going to share the Avanti. So the Avanti are the quick change soft jaws. So those are all in there as well. So let's come back to here, and I want 0 point. And what I'm going to do is I'm going to grab the base that's going to mount on this table. And that's going to be the one for, I'm going to scroll down. It looks like one of these. And it's going to be the 963. So it's this one, the 145963. Again, if I right mouse click, it doesn't allow me to insert it. So I need to open that. These, I guess, to put it loosely, is they're read only. I don't know if that's the right phrase, but you open it up. Next, I need to grab the riser. And the riser is going to be, so I'm going to look in here. And where is it? So there's a riser there. And the one I need is the 144010. So it's this one here. Double click that. That's going to open up. And I'm just opening up these first. I'm not doing anything with them yet. I'm just grabbing them all. And then next, on top of this, I have that 0 point. And that's going to be the 145800. And it's, where is it? I just saw it up here. 145800. Double click that. And then I need a vise that's going to mount into here. And as I said earlier, they're the macro grips. And I'm going to just grab the smaller one. You can really grab any one of these. I'm going to grab the 155 just to kind of match. There's the 155. Trying to find the one, this one here. Okay, so there's the vise. So I have everything I need to create my assembly. But one thing I quickly wanted to show here on the vise, the stock is modeled in there. So what you can do, you can come into here, modify, change parameters. And let me drag this over here and bring the vise down there. So what you could do, you can change the size of that stock. So Kevin Ellingson, he did this for us. He created all these models with these user parameters in here so that you can change the size. So the X size of that stock, what if it was something like 250? It's longer now. Now the Y dimension of that, what if that is, say, 125? And that's too big. You see how it's too big for the vise? So that failed. So I'm going to do something like 45. Will 45 work? Yes, it did. So I purposely did that just to show you that there's some things you need to be mindful of. That's why we have some other ones where the jaws are reversed. And we also have bigger vices in there. And then the thickness of the material, let's say it's 25 mils. Okay, so now we've got our stock. It matches. And I'm just going to close this out. So just want to expose that if you want to quickly resize your stock. Next, what I'm going to do, I'm going to go to my project. So I have my LiveStream project. I have today's LiveStream number 17. Let's go to live. I don't have anything in there. So what I'm going to do is I'm going to just save these. So I'm going to say save as. That's the file name or the document name, and the location I'm putting it in this live. So I'm going to hit save. It'll take a moment. It'll populate there. The next thing I want to do is take this plate and save it again to this folder, because once they're all saved in there, then I can add them to a document. And I'm going to create an assembly document. Okay, so I'll open that document and I'll hit save as. Again, verify I'm in the right location, and I can change that number if I wanted to. I can leave it as default. So now that's in my project. I'm going to go through on all of these and just save them quickly. verifying the location. And then the next one, same thing, almost there. Save that. And then the final device. So I'm going to save that here. Okay, so now I can get rid of these. Get rid of these guys here. Get rid of these, get rid of those. So now what I do is I have them in my project. So there's a few things we can do. I'm just going to start with a fresh document. And in this document, I'm going to save it. You have to save it first. So look, I just opened a fresh document. If I try to right mouse click and insert into the current design, it won't let me. And let me get out of that really quick. So insert in current design. It won't let me. See this error message down here in the bottom right? It says you need to save the document first. So here, I'm going to call this fixture assembly. Verify the location. Now it's saved. Looks like I have an update. I'll have to do that when I'm done with this live stream. Okay, so now I've got this fixture assembly document. It's blank. So I'll start with the table. I'll insert that into my current design, and I'll just let it drop right there. You have the option to move things around, but I'll just leave it as 0. You get a free move when you bring it in. Next, I'm going to take this one here. I'm going to right mouse click, insert that into the current design. And I'm purposely going to leave that up here. Okay. So now I want to anchor this. It doesn't matter the order. I can bring in all of these parts and then assemble them, but I'll just do them one step at a time. So first thing I'm going to do is I'm going to take this, the table, and ground it. You see that push pin there? So I'm locking that into place. And then this one here, see how that's free moving? This one I can't. So I'm going to go to my joint command. That's right up here under assemble, J for joint. You select the first thing you want to move, and you see when I hover over the bottom face, it's giving me some snap points. So I can grab this outer edge there to grab the center. Then I can come here and I can grab that outer edge. Snap that into place. I'm just going to say okay. Easy as that. So the next thing I'm going to do is bring the riser on top of this. So that riser is this one here. I'm going to right mouse click, insert into current design. And that's not in the right place, but I don't care. I like to give myself some space so I can look underneath it. Drag it out of the way. Again, go to the joint command. Grab that edge. Make sure you grab the right edge. So you grab the thing you're moving, and then the second component is what are you moving to. So I'm going to make sure I snap it there. Rigid joint. So that's this one right here. It's a rigid joint. If I wanted to rotate it, a revolving joint, a slider joint, cylindrical, pin slot, planar, or a ball, I would select something here. But I just want a rigid, so I'll hit OK. Next, on top of this, I know I need to add this one, the 45800. Again, insert into current design. And that's buried in the part. So I'm going to drag that out so I can see better. Same thing, come to the joint command, grab that center. And I can just literally just grab this outer edge to get the center, lock that in place. If I wanted to rotate it, I could. If you wanted to move it, you can in any of these directions. Make sure that's 0, so it's right on center. And then finally, let's take this vise and we're going to insert that into the current design. And like I said earlier, you get a free move. Drag it out of the way so you can see what you're doing and create a joint. Grab that center and grab that center here. And there we go. And just like that, in a couple of minutes, we've got our assembly. So what you can do, you could save this as a master assembly. And then anytime you have a new job or project, you would simply insert your part and create a joint and drop your part within that stock and start your machining. So what else? Let me look if there's any questions. All of these are joint origins. You can create those here. So you have some snap point if you like. We can get into that on another live stream. No questions. Awesome. Well, this I wanted to keep short and sweet. So hopefully you guys got something out of this live stream. Hopefully it opens up your mind to different methods and techniques and ways to hold the part and to think outside the box and to work smarter with the tools you have, and to just leverage some of the features of the part to create a way to hold it. And also think ahead when you're done with the first operation and second and third. How are you going to hold it? Are there any features you need to add? So hopefully this exposed some ways for you guys to work on your fixturing and to save yourself some time. So with that, Brad, thank you very much for being on the chat, answering questions. We look forward to doing another one of these next week. And with that, everyone be safe. And as Brad says, happy fusioning.